Software's eating the world, but AI's eating that too. Ship, learn, fix, that's how we get AI right. Look at your fucking data, keep that quality tight. Out of the lab, into the field, time to deploy. Real world problems, real solutions, that's what we employ.
Welcome back to How AI is Built. This is Nicolay, and today I'm talking to Charity Majors, the co-founder and CTO at Honeycomb. Her philosophy is that your source of truth is production and not your IDE. And if you can understand your code in production, you're truly flying blind. And in this episode, we are talking about why everything is trace-shaped and why microservices kill the traditional monitoring, why developers should own their failures, and engineers should be on call for their own code, which in the end builds better systems, and also things like metrics are overused, or why you should deploy within 50 minutes of a change being pushed, or basically die. Let's do it.
Line or anything like that?
It's the question I sent you.
Question you sent me. All right, let me just pull those up just to...
But it's, I like to be a little bit more spontaneous. So it's like more like what questions could we cover, but we see like during the conversation what threads we want to pull on.
Yeah. Okay. Yeah.
Nice.
All good.
By the way, I think that's always interesting. How did you get into engineering?
I went to college when I was 15 or 16 for classical piano performance. But I grew up really poor. And as soon as I got to college, I started to realize all of the people who graduated as music makers are still really poor when they're in their 30s and 40s. And so I picked up computers.
Yeah. What was your gateway drug? So what was like the first technology or language?
IRC.
Oh, yeah, that's interesting. That's so interesting. Nice.
IRC and then bash. Like, I was just fascinated by the Unix command line. I just hit tab. I'm like, oh my God, I can see all the commands I can run. I just start running them. Then I found the man pages. I'm just like, oh my God. So.
Yeah, I recently saw a YouTube channel of a guy who was doing the advent of code completely in bash, and I was just like fascinated by that.
Can be done.
Yeah, like lists and for loops in bash was like always the limit how far I pushed it.
Yeah, that's wise. That's wise.
Yeah. Is there a moment where you realized, hey, like I might actually be really good at this?
Haven't gotten there yet.
I'm sure you have.
No, I will say this. I will say that I got my ADHD diagnosis in 2020. But in retrospect, so many things make a lot more sense. And for me, I think it was incidents. Just like when like the site is down, everyone's freaking out. I just get dead calm and just like do the best work of my life under the most pressure. They're super fun, which is not great. It's not a great pattern to encourage. But like I would live for like those moments when everything's just completely fucked and I would just light up.
Yeah, it's like I think Pareto's law, like the projects allocates like the complete timeline you have. So like when you have like a timeline which is really urgent, like 0, you get stuff done.
Get shit done. Exactly.
Yeah. Is like how has your definition of like good code and good software evolved through the time as you progress in your career?
I think I've always felt like, the hard thing about writing code is not writing code. It's not the code. It's how it performs, how it behaves, how it maintains, how it evolves over time. But I think that since starting a company, you'll notice there are not many founders who come from an operations background. And I think that's in large part because we look for failure first, right? If you tell me something cool or fun you're building, I'm always like, how's it going to fail? And which is, that is sort of instinct is like part of the ecosystem, right? But I feel like in order to found a company, you have to be able to suspend your disbelief to some extent. You have to be able to envision something amazing. So that you have to be kind of deluded to an extent, which is really hard for people who are very focused on reliability and operations and all this stuff. And so I think I think a lot of folks start out like really seeing the opportunity, and then over time they evolve sort of a respect for the difficulty of maintenance and everything. I started out with being very attuned to the difficulty of maintenance and all this, and I've had to later in my career expand my horizons to actually the code isn't really worth anything if it doesn't change people's lives, if it doesn't move the needle, if it doesn't, you have to earn the right for your failures to be meaningful.
Yeah. Is this still something you still like? Do you think there is still a difference how you would approach a problem coming from the ops background, that you first start with something, okay, I'm going to set up like proper monitoring logging first and then start already?
Yeah. Yeah, sure. I mean, when we when we started Honeycomb, one of the first things I did was I got really annoyed with just like having to deploy my code all the time. So I wrote this little cron job that just watched for new artifacts to be built. And whenever a new one appeared, like ran like every hour, every half hour or something, just like pull it down and auto deploy it. And we still have something like that running. Like the CI/CD, runs all the tests, builds an artifact, gets auto deployed. And I think that's the best line of code I ever wrote, because it's kind of, the myth of Alexander the Great, who, the myth goes that when he was a small boy, his father bought him a little pony and told him to lift it up every day before breakfast. By the time he was a man, he'd be able to lift a horse. And I think that way about auto-deploying software. Like, it's really hard if you have a company that grows up not auto-deploying software to get to a point where you feel safe just auto-deploying every diff you make. But if you grow up that way, it just feels natural. And you're like, how could anyone live any other way?
It always pays. Like CI/CD, I think like I like to have a rule, like when I have to do something like 3 times, I automate it. And I think like CI/CD, since you have to like 3 times, it's
Constantly.
probably in the span of a week. So you
Yeah.
already like
Yeah.
do it from the get-go. Is there, from your experience, do you have any technical hill you would really like die on? Any really strong opinion?
I mean, do I have any strong opinions? My goodness, how much time do we have? I mean, your source of truth is production, right? It doesn't actually matter what it says in your IDE. It doesn't matter how beautiful it is. It doesn't matter, and if you don't have the sense-making abilities to understand your code in production, you're flying blind. And I think, people are always like, oh, what point should you add instrumentation? I'm like, as soon as you have something you're committing to a repo, because you want to know if your code works or not. And you don't know just by looking at the output of your tests, right? You don't know until you inspect the intersection of software, infrastructure, systems, users right now, right? So yeah, I'll die on that hill every day.
Yeah. I just had this week something like a bug I couldn't reproduce. Like I had it in production and I like tried to do a regression test to like first like even try out like where is it coming from, and everything worked perfectly when I was running it like locally or even from like a small server I spun up. So I like more logs in, put it into production, ran it again, like, and then first like, okay, this might be an issue which I'm finding. And it's always so interesting, like the amount of logs you can have. I think like you're either in one extremes, it's either not enough or it's way too many, but I've never been disappointed of like way too many logs.
Yeah. Well, I feel like the logging archetype is sort of, it needs to evolve, right? Like the logging archetype of just being like, for every request, it just like spews a bunch of, like, it spams, right? Anytime, it's like too often people log as though it's a debugger, right? Which the multiplier, the cost multiplier, the network bandwidth, like, it's really expensive, and it's not the proper. Like, you're not supposed to be using logs to step through your code. I think that the model that we've tried to champion, that I think is picking up a lot of steam in the industry, is the sort of observability 2.0 model of instrumenting your code, which is that it's very wide structured log lines and fewer of them, and oriented around a unit of work, right? Whether that's one wide structured log line per request per service, or whether that's several of them inside of a request, but like formatted as a trace using spans. I think it doesn't really matter. I think it depends on a lot of things, right? Like your levels, you should have sort of tiers of instrumentation according to if the service is forward facing, if it's very latency sensitive from a customer experience perspective, if it's under active development, if it's a place where lots of people collaborate on this part of the code, if it's revenue generating, those are all reasons that you should probably instrument it with tracing, right? Then there are services that are not forward facing, they're not revenue generating, they're pretty stable, right? You don't need a ton of traces and instrumentation there. One wide instrumented, but the power of instrumenting your code with fewer but wider logs is that I feel it very strongly that like data is made powerful through context. The more context you have packed together, the more powerful the data. Like, so I can't even count the number of times when I found some incredibly weird problem just because the requests that have this random subsection of dimensions, those are the only ones that are failing. Right? We actually have this thing in Honeycomb called bubble up, which is an anomaly detection thing. It's just like you see a heat map or a graph and you're like, oh, what's that? You draw a little bubble around it and we compute for all the dimensions inside the bubble versus the base size outside the bubble and sort and diff them. So you're like, oh, what's that? And boom, you're like, oh, it is all the requests that are failing that are coming from this version of Android running in this region, using this language pack, using this application, using these 3 IDs, or hitting this index, or just like if you can correlate all that stuff, it can be really fast and easy to identify. But like if you're trying to reconstruct it by reading a bunch of log lines that are spat out, each of which only have a small part of the story, it can be impossible to find.
Yeah, and I think this basically cross-correlating, you're helping the person who has to debug like formulate a bunch of hypotheses and discard like a whole lot more by doing this stuff. And I think this is really interesting. I want to trace back a little bit. Why do you think is everything shaped like a trace in instrumentation?
Because our infrastructures have been exploding in complexity across. This is not a new thing, right? It's been happening for a long time, but about 10 years ago, microservices really took off. And so much of debugging, so much of understanding these complex services is less about figuring out what's wrong, and it's more about where in the system is the problem coming from. And once you can figure out where it's coming from, finding the problem itself is often much easier. But this requires being able to reconstruct sort of like events that are happening across time, which means it's trace-shaped. And what's interesting, I think, is that if you look at AI stuff, it's all trace-shaped. This is one of the reasons, we've been talking about observability 2.0 for a while. And there are so many things about the way Honeycomb was designed, the way Honeycomb was founded, the way all of this is set up. People are like, oh, what changes? What changes with AI? What are you going to change for AI observability? And it's like, not much, because actually, like all the things we've been saying about it's software, right? First of all, I don't think you can have good AI observability in isolation, right? How well is your model performing? Like you can't just like put that out in a silo and just like because it begins when someone puts inputs in, right? And then your software is executing and it's calling out to various backends, it's calling out to various data sources, it's calling out to your model. Then it returns something to the user, and then the user tells you how good their answer was. That's a giant trace, right? And the AI observability is one part of it. And you can't answer these questions in isolation. You can't have good AI observability unless it's embedded in good software observability. This is all a trace-shaped problem. High cardinality is more important than ever because everything is high cardinality. High dimensionality, which means lots of context, more important than ever because the context is so much denser and richer than ever. What was the question?
Why everything is trace-shaped?
Everything is trace-shaped because it's all connected in time.
Yeah. And I think like in AI, we like to reinvent the wheel. So we try to start anew, and then we come back at already existing patterns. I think there are a bunch of complexities in AI which are more like in the training process. That you have to report like a bunch of extra stuff and a lot of experimentation where you're figuring out what to put in production. Where you actually like the patterns are very different, where you don't need so much observability. But once you put it into production, like it belongs into software observability, in my opinion, as well. But people like to put it into the same box that they used in training. So you don't really use they don't want to use two different solutions for it.
Yeah. No, I think it's super interesting. And from a philosophical standpoint, there's so much thought leadering going on about the future. First of all, I'm like, look, the more confidently someone's talking to you about the future and the farther out the future is, the less you should listen to them, right? The more they're like, yeah, I know it's going to happen, the less you should pay any attention to them. Secondly, I feel like 9 times out of 10, when people are thinking these big thoughts about AI, you could replace AI in that sentence with automation, and it's the same fucking thing. Sorry, excuse my language. It's the same thing. It's just more so, just faster than before, right? The circles are tightening, the feedback loops are tightening. No, that's not true 10 times out of 10, right? The introduction of non-determinism into what has been a deeply deterministic system is genuinely new. And there are some genuinely new patterns that we're discovering, that we're figuring out. But so often when people are freaking out, I'm like, are you freaking out about automation? Then maybe you shouldn't be freaking out about AI.
It's about this non-determinism. I'm so torn of where actually to handle it. Because I think this has to be pushed into the fringes. And especially onto the user. Because often you don't even know in the backend, is it wrong or right? So you actually want to highlight, and you want to highlight your confidence. So for me, it's more of a UI and UX pattern.
That's a really good point. I like that way of thinking about it.
And what are the observability practices? Yeah, you especially, you're working on it and you have seen tons of implementations. What are the practices that you have found most impactful for helping normal engineers understand their systems?
Having normal engineers understand their systems. I mean, for AI or for just software in general?
Since both are the same.
Yeah.
Both.
Yeah. I think that, I'm actually really excited about where AI is taking us, because there are a lot of places in the stack where auto instrumentation, just being able to be like, hey, Claude, set me up with tracing is such a time saver. When it comes to normal engineers understanding their software in production, I think that making sure that, I think that over the past 10 years, we've come a long way when it comes to, software engineers, you own your code in production, right? We know that this is a good pattern because it's all about hooking up feedback loops, right? If the feedback loop consists of, you've got half of the team writing the code and the other half on call for it, that's a broken feedback loop, right? The people who need to be changing the code to make it better are not getting the pages, the alerts, you need to tighten that up, right? And so giving them good tools to understand their software. So many of our observability tools were built back in the days of when it was such an ops domain. And so you had to understand, if you're an engineer writing code and then trying to understand it when it comes out, you have to learn how to translate things like API requests and function calls and variables into all these different CPU percentages, and there's all these different kinds of memory, and that's asking too much. That you can't ask all software engineers to also be infrastructure and operations experts, right? So you need to give them tools that speak to them in the language of their software. Endpoints, APIs, right? Variables, functions. And it needs to be something that they don't have to break flow, right? They don't have to break their mindset. So then giving them tools, holding them accountable for the quality of their code. None of this is rocket science, right? But it is evolving pretty fast.
Yeah. How do you think actually about turning the metrics, logs, traces, profiles, errors, whatever you have? How do you think about actually turning that into direction and action that the user, the developer, can act fast and swiftly to actually fixing it?
I think that one of the biggest, so first of all, I have a reputation for hating metrics. I don't hate metrics. I just think that they are really dramatically overused in the wrong places. Like, we treat metrics like the workhorse of telemetry, and we treat structured logs and traces like the special, stuff. It should be the opposite. Rich structured data is the workhorse, because if you throw away all of the connection bits between your data at write time, you can never get them back, right? But if you capture your data in these arbitrarily wide structured log events, you can derive metrics from them. You can derive traces from them. You should be able to store your data once in like a consolidated place where there are no dead ends, instead of storing them in like 5, 10, 20 different siloed data. Like, there's this huge cost crisis going on in observability right now. And a big part of that is because most of the teams out there are using 10 to 20 different tools. So every request that enters our system, they store in 10, 20 different tools. So it's like a 10 or 20x multiplier in costs. Like, their business is growing like this, and the cost of their observability is growing like this, right? It's unsustainable. And it's worse than that, because it's not just about the cost when you store it. It's that what connects this 10 to 20, that 10 to 20 tools number is a Gartner number, right? Which I'm ecstatic to have it, because I've just been saying 3 pillars. It's many pillars. What connects these 10, 20 pillars? You, the engineer, sitting here going, well, that shape looks like that shape, so they're probably the same thing. It's absurd. Like, it's so hard. Anyway, structured data is the workhorse. Metrics data is the specialist stuff, right? It's the stuff that when you need a counter, right? Or when you need something really high velocity. What was your question? We were talking about
how you turn like the logs and traces into action.
Yeah. Great, thank you. How you turn logs, traces, metrics, errors, signals, all these things into something usable by engineers, right? I think that one of the biggest cheat codes is just giving engineers tooling that has this connective tissue, and then building the muscle memory that after you ship your code, you go and you look at it. You look at your instrumentation. You look at it through the lens of the instrumentation you just wrote, and you ask yourself, is it doing what I expect it to do? And does anything else look weird? Right? You can't be in a position where you're just looking at stuff when you already know there's a problem, right? If you only look at your instrumentation after you've gotten paged that something's broken, you're not developing the muscle memory. You're not developing the informed gut, right? I feel like what separates really senior engineers from less senior engineers is how much can you trust their instincts, right? Your instincts need to be trained not just on outliers and errors. It needs to be trained on what feels normal, right? So just making a practice of, you instrument your code, you deploy it, you look at it, and you ask yourself, I feel like there's some irreducible complexity there. Is it doing what I expect it to do? And does anything else look weird? Like, if you can't answer the question, is it doing what I expected it to do? You didn't add enough instrumentation. You should be able to validate that. You should be able to say, okay, I just changed the compaction, whatever, and here's how much it is storing before, and here's how much it is storing after. Great, it's doing what I expected, right? And does anything else look weird? Because you don't always know what to look for. But so that's I know that sounds super basic, but I think that's where we're at. I think we're at a super, super basic place. And in order to make this a really valuable action, there's more that goes into it, right? We need to decrease the amount of the interval between when we write the code and when we're looking at it in production, so that it's a short enough interval that we don't have enough time to page projects in and out of our head, right? An hour at most, maybe. We also need to make sure that we are not deploying each person's changes along with 20 other people's changes. Ideally, we're deploying one person's changes, right? Or only one person who's working in any, given part of the code base, because otherwise you're asking people to look at something that it's like a very muddy puddle, right? So there's a lot of this that is just good hygiene, right? It's a lot, but it all comes down to, how do we help people understand the impact of what they're doing when they still have all of that original intent fresh in their head.
Do you think this should be triggered? Looking at your traces should be triggered basically once your commit, it's merged, pull request in, it's deployed. Should it be triggered automatically even if nothing is going wrong? Or should it be only done based on a flag when an error is raised or something.
I mean, this depends on your. Wait, what do you mean by triggered? Turned on or?
So basically, when your code is deployed, should you always look at the logs, or should you only look at it when an error is raised directly after the deploy?
You should always look at your code after you've deployed it, and because otherwise, like it's not. So one of the big mental shifts that I think we need to make is that observability is not just about errors and bugs and problems and getting alerted, right? It's about understanding our software. And there's a lot to understand that is not just because it's failing, right? You need to understand how it's behaving, who it's affecting, right? And I think that part of this is building up that rich mental model of what we expect to have happen, and then we go and look for that. It's not, yeah, I think that if we're just looking at, I mean, maybe your error handling stuff isn't working right, you know?
Yeah, I think like in AI, we're actually closer to that, especially at the moment.
I
Like it's
agree.
always just look at your data. So you spend a
Yeah.
lot of time looking at the unstructured stuff
Yes.
to actually figure out like what is going on, because the behavior is non-deterministic.
Yeah. Mm-hmm.
And
Yeah, and I think there is some really interesting sort of muddy crossover stuff here because any sufficiently large and complex system also does not it behaves deterministically as we would like it to. You know, there's weird stuff going on all the time under the covers, and historically we just haven't had enough detailed fidelity data to be able to identify that stuff. But you know, there's this thing that happens chronically as we're rolling out Honeycomb with new customers. You know, is they start going, "Oh, what's that? Oh, what's that?" And it's just, and they're like, "Oh, wait, we need to stop and fix it." And it's just like, "Oh, grasshopper, that's been there for how long? You couldn't see it, you couldn't find it because all you were doing with these metrics, you know, they're just falling off, so you can't tell the correlations, right?" But like, there are so many things broken at any given time that are just like, they're not broken enough to trigger a paging alert, or you don't have an alert set up on them or whatever. And so, you know, I think that another like really important sort of threshold as you're graduating, getting better observability with, you know, more contextual data, is that a lot of us grew up, you know, setting alerts and alarms on symptoms, and that there's a point where that just doesn't scale. It doesn't work. I think I just had another network blip, but hopefully Riverside took care of it.
yeah,
It
Riverside got
doesn't
it.
scale. It doesn't scale because you need to get to a point where you're using SLOs to be, you know, watching the critical path, whatever's making you money, whatever your customers are sensitive to. You define these SLOs, and you can delete like 90% of your paging alerts, because those paging alerts are just, they're flappy as hell, right? They're flappy, and they're not actually looking at what is most meaningful, which is, you know, the SLO path. But the trade-off that you're getting there is, yeah, you're no longer paging yourself all the time. So you need to actively go and look at your data, you know, because otherwise, yeah, it's just a sort of push-pull. It's better to be looking at it and affirmatively finding these sort of small problems, quote unquote small problems, than to be paging someone all the time, but they're still there.
Yeah. And when you train up a new organization, like you're coming in as Honeycomb, how do you actually teach them like what is important, what is not, how to use the tools, when to use them? Like, how do you get an organization up to speed in observability?
You know, that's really, I think that's probably one of our most unsung strengths is just that, you know, we're experts in open telemetry. We'll help people re-instrument. We'll help people figure this out. But when it comes to like, how do we help teach them what is important? They have to tell us, right? Every company is different. Every company makes money in different ways. Every company has a different set of things that are important to them. So, you know, we can sit down and help them work through this, but like, it's unique, right? Every company. But there's, when it comes to defining SLOs and doing instrumentation and rolling this stuff out, so much of it comes down to just like curiosity, and that your tool is not punishing you for looking at, you know, I remember there's so many times I like put someone on call for the first time, and they're kind of like nervous and excited, and they see errors and they're like, "Oh, what's that?" And in the battle days, I'd be like, "Oh, don't even bother. You know, you could waste days chasing after these errors, trying to figure them out, and you'd never figure them out, and you just, you know," which is right? That kills curiosity. Ideally, anytime you're curious about something going on, you should be able to go and figure it out quickly, easily, get on with your day. So I do think that our tools are dramatically improving, and AI has a lot to do with this.
Yeah. How do you think AI will impact this as we actually continue to write code even faster?
Oh, God. Yeah. You know, the origin story of Honeycomb, Christine and I both met at this little company called Parse, which was a mobile backend as a service, right? You've got a mobile app, you use our APIs, SDKs, and we do all the backend stuff. So all over the world, we had like 1 million users, 1 million mobile apps by the time I left every day. We've got all these developers out there just sort of writing snippets of JavaScript and uploading them, and we just had to make them work, right? Some of them are interns, some of them have never no discipline, right? We just had to make it work. And I feel like what everyone is going through now really resembles those days, like at Parse, which was like the origin story of Honeycomb, right? Like, how do you deal with all this code of unknown quality, right? Everybody's going through that right now. And there are a lot of things that you can do when it comes to instrumenting your code so that almost everyone is accustomed right now to debugging through expertise, right? Something breaks, something gets deployed, something breaks. The knee-jerk response is to look for who wrote this, who built this, who's an expert in this. Somebody out there presumably deeply understands this thing that has been rolled out. Thing is, you can't guarantee that anymore. If you ever could, you really can't now. And so understanding software on its own terms, right, with no expertise, is kind of the name of the game. And there are things you can do, like, generating the number of the line, the line number of the code that generated, say, a database request, right? You can drop that into the database comments as it's executing, and then you can log that out in your wide structured log, right? You can do a lot of things to help you trace back. But the problem of original intent is kind of one that you can't actually reconstruct what was in someone's mind while they were trying to do this. So, yeah, it's hard.
I often can't do it. Like when I'm looking at some code 6 months after I wrote it, I'm looking back.
What was I thinking?
Why did I even do this? I'm not sure anymore.
Yeah. But again, which is why I think it's so important that this is like the oldest, most boring topic, but I'm going to keep ringing this bell. Shrinking that interval between when you are writing the code and when it's in production to be as short as possible is like it. These are socio-technical systems, right? Which means that they're made up of feedback loops. And the shorter and tighter the feedback loop, the easier it is to debug and understand. And I almost can't stress it enough. Making it so that it's a matter of minutes, maybe an hour, maybe two, between when you're writing the code and when it's in production, is like the foundational feedback loop that so much of this stuff is built upon.
What are the practices that are behind it? Like shrinking the interval between when you write code and when it goes live? Like, what are the concrete practices that actually allow that stuff?
Yeah, I mean, one really nice starting point is to instrument your CI/CD pipeline as a trace, so that you can see where the tests are taking time, where they're laggy, where you can parallelize, where you can, and just like setting an internal SLO for yourselves, like, if it gets above 30 minutes, we are going to reallocate some engineering cycles to pay this back down, right? Just keeping it tight, because otherwise it grows unboundedly, right? You write a Rails app and it's like 5 minutes to deploy when you start, and then 3 years later it's going to be 5 hours. If you don't constantly pay that down. So set an internal SLO, instrument it as a trace. Other things you can do are practice things like progressive deployments, where you've got something we do at Honeycomb is we've got production, then we've got the dog fooding. So all the instrumentation that goes from production goes to the dog food cluster, and then all the instrumentation from the dog food cluster goes to the kibble cluster. So then when we're rolling out code, we can roll out code to kibble, and then to dog food, and then to production, right? So there are ways to kind of bridge the gap between. It's a little scary if you go from writing the code to everyone in production using it all the time within 15 minutes, right? But there are stages that you can create. You can also do progressive deployment using like canaries, where you deploy it to a single host first, and then you watch it for a while. Or you set up alarms that let you know if it diffs too much, or you set it up to automatically deploy to one host, then 1%, then 5%, then 10%, then 20%. There are a lot of things you can do. Feature flags are another really big one, because conceptually separating deploys from releases is necessary, because what do engineers need? They need changes to go out constantly and to be very small, right? Smaller diffs more frequently is the number one thing that anyone can do for better, more reliable, more stable systems. This is in tension with other needs of the organization, like the needs for marketing or for product to do product releases or to have marketing events. And so, making it so that you can do steady, small diffs going out all the time, but then in a very controlled way, turn them on for small subsets of test users or flip them on immediately for, big events is super necessary. So those are a few of the things you can do.
What is the difference between your Kibble servers and the .fully server? What is happening on these two servers? Who is seeing it?
So Honeycomb is basically an instrumentation and observability company, right? So we've instrumented our own code. So the code that we instrumented in production, that telemetry gets sent to the dog food cluster.
Yeah.
And that code is instrumented. So the telemetry that gets instrumented by the dog food cluster goes to the Kibble cluster.
That's so interesting. I really love that. I think in general, that's the really great post you have written. I really love that. Reducing the fear people have of putting stuff into production and pushing it up.
Yeah.
And I think this progressive deployment part is one. Small changes is another. Good tests is another one. Are there any other factors more on the social side which actually help?
I think that the social side is, you look at your code in production after you change it is one of the social ones. Also, just having a culture of learning and discovery and curiosity. The code the code that any of the changes that you introduce to your socio-technical systems that make it easier for people to learn, to self-serve, to come up to speed. I wrote this blog post recently called In Praise of Normal Engineers. And it was talking about how when you're building socio-technical systems, when we're hiring, when we're recruiting, when we're building our teams, we tend to look for all the ways that people are exceptional and things that they're great at. But when we're building these socio-technical systems, we should build them for all the ways that we are normal, right? Because even people who are exceptional engineers, they're normal in more ways than they're exceptional, right? And your socio-technical systems should not require you to be a superhero just to get shit done on a daily basis. They should be navigable by normal engineers. That normal engineers get tired, right? Normal people, our eyes are drawn to the color red, right? There are things that, and if you make it so that your systems incorporate things like design thinking, product thinking, instead of, we tend to act like engineers aren't human beings sometimes, right? Look at the interface for Vim or Emacs, all the things you have to memorize, right? These were not designed for humans, right? Our socio-technical system should be designed to be easy. It should be easy to do the right thing and hard to do the wrong thing, right? And if you build socio-technical systems with those principles in mind, it's easier for everyone. And that work will get used and reused over and over again. It gets used whenever you're onboarding a new teammate. It gets used whenever you bring on a more junior engineer. It gets used whenever you have engineers that are moving between teams, right? The less of your genius and brilliance has to go to just navigating, getting a deploy out, the more you have to devote to your actual work.
Yeah. I think my best, even if you think you are a genius, write for yourself at 4 o'clock when you get woken up after 2 hours of sleep and you have to debug a major issue.
Yeah, good luck.
It's so interesting. And I think still the AI perspective also for that, because I think AI is the epitome of the average Joe engineer.
Yeah.
How do you think, is there a difference of making it easy for the AI to do the right thing as more automated coding tools become the norm, as it is for getting the normal engineers to do the right thing?
Yeah, probably. I don't know. What do you think?
I think having a really good code structure and good layouts will become even more important.
Mm-hmm.
And also, especially like figuring out a good semantic meaning. I think humans are way better at contextualization because many companies have like internal lingo they're using and the humans know it. AI won't. Like just tokenization will be a massive pain in the butt. So using better terms which are regularly accepted, which are semantically meaningful, like just naming file layouts, will be massively important.
That makes a lot of sense. We just did an AI hack week at Honeycomb, and one of the demos, it was really cute. They were like, "Do you want to hear the responses in like Gen Z lingo?" And they had a couple others, and one of them was like Honeycomb. And I'm like, "Oh my god, I want to see what the Honeycomb lingo was." And of course, it swears. Yes, nailed it.
Train it up to be good. I think it will become really interesting what we are seeing. I think also keeping a lot of code together will pay off as well. Because like code that basically belongs together, like what we're seeing already, like it's really good at React with TypeScript because all of it is like one file which belongs together and like 3 separate ones.
That makes
And
sense.
I think we will see more and more of that, but I think we will also have like the downside that we will all be pushed into a certain tech stack.
Yeah, makes sense.
Yeah.
Mm-hmm.
To get back on like the interesting topic, how do you think about like how should organization think about balancing investing in internal tooling and delivering like more customer facing features?
Yeah, this is a really good question. I I was having this conversation with a CTO almost a year ago now, and I don't remember how we got in this topic, but we started talking about internal tooling, and I was like, well, and he was saying something about how the most senior engineers. Oh, right. He was talking about how he was like, well, you really want your most senior engineers out there writing new features, and don't you want to just hand them off for maintenance mode into engineers who are not as good? And I just kind of looked at him and was like, no, like I want, like typically writing features is like not that hard, and your most intermediate senior engineers could like chunk that. I want my most senior engineers to be building the infrastructure to enable those engineers to like chunk out. And he just kind of leaned back. He's like, sell me on that. And I'm just like, how is this not obvious? It is so much. I don't know. It was weird, just sort of like two very different mental models colliding. I just had another internet blip, I guess. But so many engineering orgs waste so much of their engineers' time by underinvesting in the systems that they use for making sense of their system, for shipping the code, for for making observability like uniform and well structured, and I'm sure it's possible for companies to err on the other side where they're over-investing in internal tooling and not enough in making forward progress, but I don't know that I've ever seen it. I think almost every company I've ever seen is under-investing in their own. And part of this is because, I'm writing this, it's metastasized. This is enormous couple of blog posts on cost control for observability. But I'm realizing that it's gotten a lot easier to quantify the way in which performance hurts companies from the perspective of the product and user experience, right? There's so many articles out there about like, oh, Amazon discovers that, every extra 100 milliseconds of latency makes them lose, like, I'm making these numbers up, like 20% of their shopping cart, conversions. Or Google is like, if search doesn't return in X number of seconds, then we lose millions of dollars. We've gotten a lot better at quantifying that stuff. And when it comes to engineering efficiency, it's still very vibes based, but it's real. Like when it takes you 15 minutes to get your code into production versus if it takes you 15 hours. It's like you enter, like, I've called it like the death spiral of software engineering, where everything takes so long that people have forgotten what they've written by the time it's in production. And so it takes even longer. So you need even, like, you ever see like a company that has like 800 engineers, or a company that writes a simple mobile app and you're like, oh, that's a cool app. Fuck, they have 800 engineers. What are they all doing? Well, I guarantee you that's a company that has very poor internal discipline around tooling. And as a result, they all sit around waiting on each other a lot of the time, or creating problems, or not being able to solve problems in an efficient amount of time because their feedback loops are so long and so lossy that now they need specialized release engineers, and they need specialized SREs, and they need more managers, and they need more product folks. They need, they need more and more people, and it becomes incredibly expensive to ship this software. Not only that, it becomes miserable to ship that software. That is not a fun place to be an engineer. Anyway, I think we're just really bad at quantifying and like turning that into a compelling argument for when is it, which is why I think that starting with internal SLOs for engineer experience is where I would recommend most people start.
Yeah. Because you always mention it, like normal engineers, what do you think distinguishes exceptional engineers from normal engineers?
I think most normal engineers are also exceptional engineers, but they're exceptional at a couple of things, I identify as a normal engineer. I spend a lot more time being normal than I spend being exceptional. And I think that here's the thing about normal engineers. The best way to make world-class engineers is to put them in an environment that values learning and collaboration and creativity, where people are excited to get to work, where they're having fun, where they dig into problems and they get really into them, and they take it all away. And the best way to not build exceptional engineers is to build an environment where there are appeals to authority, where projects get canceled and shut down, where people just get kind of jaded and bored and check out. But like, we're all born with creativity, and like we become engineers because we love solving problems, right? And if you build an environment that rewards that, those are the places that I think mint world-class engineers like no one's business.
Yeah, I think there aren't really exceptional engineers, like, to the true term, because like being exceptional means like you're good at like most stuff, which no one is. I think we all have like glimpses, and a few people have like the glimpses rather often. I don't.
I have definitely worked with some incredible engineers. But there's a separate question too, which is the engineering bar. And this is tough because this is really hard to tell from the outside, right? There are places where the engineering bar is higher. It needs to be. It has to be, because the stuff that they're doing is really technically challenging. But I think that there are a lot of places where it's not actually that hard, and very normal people with a normal amount of experience can be very successful. And I think that we get very judgy, and we attach, we get, I don't know, we could rabbit hole on this question for a very long time. I've worked with some incredible people, and I will just say that in my opinion, the way that you build these incredible people is you build a place that rewards generosity and caring and excellence.
Yeah, I agree on that part. I think like AI feels more and more like you're just sticking a few Lego blocks of different APIs together, and not that you're doing any engineering anymore.
I don't know. I feel like there is going to be a bit of a bifurcation of the software world into disposable code and not disposable code. Disposable code will be the kind of code that nobody ever really needs to understand. If it doesn't work the way you want it, you'll just tear it down. You'll generate it again. You'll generate 10,000 more. You'll let them fight it out to see which is best. But then there's the software that runs the world. The banks, the delivery companies, the stuff where, from a risk arbitration perspective, the idea, somebody's got to understand it, right? And I think we'll use AI to get better at understanding it. But I think that there's always going to be a need for real engineering. I do.
Yeah, and when you have the case, when you run into that, like, we have to debug a system that no one really understands anymore. And I think we will run into that, especially in finance soon, because we run out of COBOL engineers.
Yeah, true.
How do you think, like, how should one even approach that problem?
It kind of depends on the problem. depends on what you have. What artifacts do you have? What evidence of workingness do you have? But I think that you're tapping into sort of the next frontier in AI, which is how do you define what good looks like? How do you define this? How do you set those parameters? How do you tell? And I don't have any answers there. Do you?
Yeah. I hate the word good, to be honest,
Good
when it
enough.
comes to AI, because it isn't specific enough.
Yeah.
Because if you, especially like with LLMs, it's like it's even more fuzzy than regular AI. I can't quantify it anymore because I can't put like classification metrics on it.
Yeah.
And so it's really fuzzy. So when someone says, hey, this text is good or it's not good, it's completely useless.
Yeah.
So I really need to I need subject matter experts which actually help me, okay, what makes this good and what doesn't? And then I can start to actually figure out, okay, how can I evaluate it and put like a number on that.
Makes a lot of sense.
Yeah. In your blog post, you also mentioned you will never know what code you wrote does by just reading it. So I think like starting that problem already starts in like first like putting up some tests and running it, and then looking at the logs to understand the behavior of the traces.
Yep. No, if you're trying to debug your code by reading the code, I hope that your code is very simple because, I just can't. The number of times that I have made a mistake that's just like, oh, I should have put 1 plus there instead of 2 pluses. It's just, we're not good at this. We're not good at this.
Yeah. And especially like we AI people, we use Python a lot.
Yeah.
So often we have the wrong types.
The types. Yeah.
Yeah. It's so interesting.
I am not worried that we're going to run out of problems to solve. Let's put it that way.
Yeah. By the way, I'm really curious. Like, what is your tools of choice? Like your editor, programming language that you spend most of your day in?
I don't spend most of the day in any programming language right now. It's been a while since I have. But when I did, it was probably Ruby.
Interesting. I never touched it. I think like Ruby is apparently one of the languages that a lot of people feel like so productive in.
Yeah. It's very terse.
Yeah. Nice. Do you think we, as an industry, move more and more into a direction that we will handle a lot more software of unknown origin?
Yes, absolutely.
Do you think we should limit it, like enforce an SLO that you actually have to understand? Like you should, like an engineer or like all our engineers should understand 60% of our code base.
I think that sounds absolutely lovely and absolutely unenforceable. Yeah, I think we're just going to have to get better. I think that like it's telling to me that we started the AI revolution by writing code. It's never been the hardest part. It's always been the easiest part, which has been obscured for a long time by the fact that it hasn't been easy. But like I am encouraged that I feel like people are starting to turn these very powerful AI tools towards what happens on the other side of generating code. How do we understand what's happening? How do we understand the long-term effects? How do we understand if there have been regressions? How do we create this sort of shared understanding? And what does understanding even mean? I'm really excited to get some better answers there.
Yeah. What I'm really hopeful for, because I think it's becoming cheaper and cheaper to write code, so it's also becoming cheaper to throw away code. Mm-hmm. So I hope we just throw away a lot more and see whether it has an impact and rewrite it in different ways.
Yeah.
What is the biggest bullshit you've encountered in your tech career?
The biggest bullshit I've encountered?
Yeah.
Oh, God. I don't even, okay. Some big bullshit I have encountered in my tech career. A lot of it has come from VCs. In fact, I probably shouldn't. You're going to have to be more specific. What kind of bullshit are you interested in hearing about?
I'm especially interested on like technology choice, like how to handle developers, how to implement stuff, and especially stuff that everyone else seems to agree with.
For a long time, everyone just agreed that you never put developers on call. They couldn't be expected to actually own their code. They didn't. Like, I started talking about putting developers on call back in 2015, and people got mad about it. They were like, I didn't become a software engineer to get woken up in the middle of the night. How dare you? And I'm like, well, somebody's getting woken up. there's just this like engineering classism just sort of embedded in that worldview that like they're too good to like handle their own shitty code, you know? Not a fan of that worldview.
I think there is a real difference still between like US and EU. I think like being
Okay.
on call in the EU is like really seldom. Like I think I've never spoken to an engineer in the EU who has been
It's coming for
really on
you.
call.
Yeah, it's coming. It builds better software.
Yeah. Like you're being forced to write good software because you don't
You
want to be
you don't
waking
want
up
to be
at
woken
4 a.m.
up in the middle of the night? Absolutely. Yeah, it's coming.
What is the most important non-technical lesson you have learned running your business?
Oh, you know, it is really a fluke that someone like me started a company, and I still can't believe it's still around. Honestly, not most important. You know, I think I used to. I don't really know how to say this, but I've been an employee a lot longer than I've been an employer, and so my sympathies are usually with employees when they're, you know, because I know a lot of people have really had bad employment experiences. You know, they've worked for people who were unscrupulous, who were, you know, evil, who really were, you know, just like did not care about their employees at all. Um, and it's weird for me now to be on the other side of that and just feel that, I don't know, that suspicion. You know, you work so hard to do what's right for your employees and they still react with like paranoia because you can't tell them everything, you know? I'm a big fan of transparency, a huge fan. Like, I have been in the position of where our founders weren't straight with us and I hated it. It did not make it easier for me to do my job. And so Christine and I have always had a very high bar for being transparent with our employees. Um, I don't know where I'm going with this. I think what I've learned is that there are, you can't make everyone happy. Some people are always going to be unhappy and you can't take it personally because sometimes it doesn't have anything to do with you. And you still have to do what's best for the organization. You can't just, you have to try and be consistent. You have to try to be fair, and you have to put the health of the organization above any individual, including yourself. And people are never going to thank you for it or be grateful and you can't do it expecting people to be happy with you because they're never going to be happy with you. And you have to have a sense of an ethical background and an ethical backbone, and you have to do what's right anyway. I
Yeah.
don't know if that made any sense.
Yeah, it does. I think someone who runs a really one of the unicorns in Germany once told me like the more people you're responsible for, like at a certain point it comes to place where every decision you make will impact someone negatively.
Yep.
And this is the point.
You can't be
Yeah.
paralyzed by that.
And there's the points where also like transparency starts to become increasingly difficult because you always have someone yelling like this isn't right.
Yeah. And I think just in the past year, I've really had to rethink and redefine what transparency even means. Not just, there's been a few sort of generational, in the beginning when it was just half a dozen engineers sitting in a room, we talked about everything, right? I took VC meetings right out there in the open, right? But at each sort of step of company growth, there comes a point where I'm actually not doing my job if I let everyone get distracted by the ups and downs of, you know, oh, a VC said no to us, or oh, someone doesn't think we're going to make it, or oh, you know, they don't need that play by three. It's just going to be so noisy and distracting and disturbing. Like transparency means really, truly letting people know what's going on with the business so that they can make smart decisions about how to prioritize and spend their time, right?
Yeah.
It doesn't mean like relaying every blow by blow. In fact, that's like malfeasance if you do that. And so there's this great blog post that Tim O'Reilly wrote over a decade ago. And the title is How I Failed. And in it, he's very introspective about some of the things he wished he had done when leading O'Reilly Media. And one of the things that he said was, you never know what book you've written until you find out what book people read. And I've been sitting with this, and I'm just like, that is such good advice. You don't actually know. And I've taken it to heart internally at Honeycomb, in that I think for a long time we've been transparent in a way where we're giving all this narrative, like here's how we're doing. We have an employee who sits in our board, and after every board meeting, they report back to the company. But so often an employee will be like, we need to be more, why won't you be more transparent about this? And it's like, we've told you that 9 times, we've told you guys this. Why are you complaining about lack of transparency? We've told you all this. But instead of getting mad at them, it's like, okay, they're not hearing it. Right. So we've started, instead of just giving this narrative about how we're doing, we're now having like finance prepare a report that's just like 4 or 5 color-coded spreadsheet rows, but it's the same rows at the end of every month. And we share that with the company in chat. And then we talk about it briefly in all hands. And so we're actually sharing less information, but it's the book that people are reading, right? Are they actually able to hear it and contextualize it and understand it?
Yeah. It's always like what's important to people, but also like what's relevant to them right now and what can they process in their current state of mind.
Yeah. And I started getting some feedback that the amount of transparency could be overwhelming. And so that's not good either, So yeah, it's a constant work in progress.
Yeah. Because the big book stack is behind you, what's the technical book you would most recommend? And more interesting, what's the non-technical book you would recommend the most?
I have been loving Will Larson's writing for years. And he is working now on a book about engineering strategy, which is the first that's ever been written, I think. And I am so excited for it, because strategy is one of those words that you hear all the time. And mostly people just mean things like plan. But strategy is an actual real thing. And it's really what separates the good companies from the bad companies, is having a strategy and knowing how to execute on it. So very much looking forward to that. I also really like Sarah Drasner's book, Engineering Management for the Rest of Us. I think it's very good. In terms of non-technical books, I'll reach again for this book by Richard Ramelt, who's written, looking at The Crux, and there's another one. He writes about strategy from a business perspective, and he just has this withering, dry sense of humor when he's talking about all the ways that people misuse the word strategy that I find entertaining. There's also this book called Fluke, which I grew up religious. I'm not religious anymore. But I read this book, Fluke, almost a year ago. And it's about, it's hard to sum up kind of. It's about history. There are kind of like 2 big schools of thought when it comes to history. And one is like the great man of history, right? Where you've got these great people who like move mountains. And there's another side that's kind of more on the scientific side, where they're like, well, history is kind of like predetermined, and who actually done it is kind of like like there are like 5 people who are about to invent the light bulb at the same time. And so it's like convergence and coincidence are like the 2. And this one is like, it's fascinating. We crave narrative, right? An example that he uses is the Harry Potter books. If at the end we had defeated Voldemort because Voldemort slipped in a banana peel and cracked his head, that would not have been a very satisfying story. But that kind of thing happens in reality all the time. And so, if you think a lot about what in life has meaning, and does anything we do ever matter, it's a really comforting, the answer is yes. Not everything we do really matters, but you never know when something that you do could actually change the course of other people's lives, right? And so everything we do really does matter. And it's just a beautiful sort of, I'm not religious anymore, but it's when I do think a lot about meaning in life. And so it's a good book. It's called Fluke.
I'll find it. I just read Tiny Experiments by Anne. I will butcher that name because it's French. Anne-Laure Lecunf, something like that. And she has a story in there about the Chinese man, which is really like the anti-narrative guy, I would say. Like basically, he finds a horse which runs to him, and like everyone is congratulating him, and he's saying like, okay, maybe it's good, maybe it's bad. and then like the next day his like son is taking it out, he falls from the horse and breaks his legs. Everyone is like, oh no, yeah, you lost like a worker. And he's like, maybe it's good, maybe it's bad. Like the next day the army is coming into town and drafting like every of the other people's son but his son, because his leg is broken. And everyone is like, okay, like hurrah, like your son isn't being drafted. And he's like, maybe it's good, maybe it's bad. So it's like often you can't tell after the fact, and we always want this like narrative, but we can't really put a pin in it.
Yeah. Great.
What's next for you guys? Like what's next at Honeycomb? What is something you're at the moment really excited about?
I'm really excited about our AI stuff. One of the difficulties in talking about AI is there's so, like, it's such a small world, and it's such a small word and encompasses so much. Like there's on the instrumentation side and stuff we're embedding into our product, and there's stuff that we're using internally in practices. And it's been kind of, we have a lot of ops DNA in our company, which means we're kind of skeptical and we're kind of cynical. And so it's taken a little bit, but I think the whole company's really excited about it, and I certainly am.
Nice. And where can people learn more about you and Honeycomb and follow you guys?
Honeycomb.io or charity.wtf is my personal site. Or I am not really on Twitter anymore, but I'm on Blue Sky at charity.wtf.